Hi everyone. So today is May 11th. This is the asynchronous work for today, and we're talking about engineering forces. All right, so a reminder of where we've come because we're going to have a quiz this Friday, and that quiz will be on everything from the past 3 weeks. So we have, in that 3 weeks, we've talked about the engineering design process. We've talked about criteria and constraints. We've talked about transportation systems and subsystems, and also the structural subsystems. And then today is forces that engineers consider when they're designing structures. So this is the last day of new content for this quiz that's coming up on Friday. All right, I think we're still struggling with this, so I wanted to give you another chance to review. So pause here and see if you can name and describe those 6 transportation subsystems. Go ahead and pause. All right, hopefully you were able to get those. Remember, we have structural, propulsion, guidance, suspension, control, and support. And we'll talk about those, or we'll do a little bit of practice with those again in class today. All right, so we have 5 forces to study today. And all of these will also come in handy when we are talking about bridges over the next few weeks. So the first 3 forces are tension, compression, and torsion. Tension, you can imagine, this is a force that stretches an object, so you can imagine like pulling a wire, pulling a rubber band. There's a lot of, in bridges next week, we'll talk about how tension plays a part. Compression is like if you put your hands together and you push against them, that is compression. It's a force that pushes inward or into something else. Torsion is a twisting force, like wringing out wet clothes. So that would be like this, right? Twisting. This happens a lot because of wind in the natural world. So like some really tall buildings are built with a lot of torsion in mind because of the wind. All right, and the last 2 forces are bending and shear. Bending is when one side of an object experiences tension and the other experiences compression. So this doesn't matter too much for something like paper, which is really flexible, but let's imagine that this is a board, which is much less flexible. So if something were to come right in the middle of this between my hands, it would bend down, and that means that the top side up here is experiencing compression, and the bottom side is kind of getting stretched out. And eventually, if this were a board, if there was enough bending, those 2 forces would cause that board to snap. And then shear is the force of 2 sides pushing past each other. So this is the same force that is involved in a transform plate boundary, so we can use that same hand motion to remember shear forces. Okay, let's go through a couple of examples just to make sure we have that. So tension force, this is a couple of people playing tug of war. They are pulling against each other on this rope. That's tension force. If they pulled hard enough or the rope was weak enough, that would eventually break because of the tension. All right, here we have what I was describing before. So let's imagine that this is a bridge, just a flat bridge across like a river or something. We have these beams here and then the flat surface. And then let's imagine a really big truck is going across that bridge, and so there's some weight in the middle. That weight is pushing down right in the middle of the bridge, and it's going to have a really hard time supporting that weight right in the middle away from these 2 beams. So while that weight is going down, the top of this is experiencing compression because those sides are kind of pushing together between here and here. Those are pushing together. And then this side on the bottom is being stretched out as a result of the tension there. So this is the overall together, this is a bending force, and we can see that there is both compression up here and then tension down here. All right, and then this is an example of torsion. So torsion kind of just means twisting. You can imagine that, twisting. All right, that's all I have for you. Go ahead to Google Classroom, complete the form. There is a claim evidence reasoning at the end of that form. Please make sure you're doing that in complete sentences. That should be a full, complete paragraph. I'll see you in class.